I'm Pramod Beesal. I am an IIT Delhi graduate and currently an RSME officer. In this video, we are going to discuss about the microprocessors architecture basically. So we'll be looking at the basic components of any microprocessor and how exactly are they interrelated with each other and what are their main functions of all these components. Okay, we will be again taking them up in detail when we talk about 8085 architecture, but that will be in our upcoming videos. Okay, so we have already seen that a microprocessor has these three parts majorly. One is called as the ALU, another is register array, and then is our CU. Okay, so when I say ALU, it is basically our arithmetic and logic unit. So I'll be able to perform all the arithmetic functions. And what are arithmetic functions? Like our basic mathematical functions. It could be addition, it could be subtraction, multiplication, or division. Clear? Similarly, we will be able to perform the logical functions also. The logical functions would be less than, greater than, equal to, not equal to. At the same time, we can perform the Boolean functions also here. Boolean functions means based upon our zeros and ones, means binary functions only, and the results are also going to be in binary form, means either 0 or 1. So there can be OR function, AND function, XOR function, NOR function, that sort of functions also we can perform with the help of an ALU. Now ALU will be performing all these functions based upon the instruction that are given by the processor. Okay, so when I say instruction or when I say the program, okay, so a program is basically a set of instructions written for the processor to perform a task. Okay, so whatever task or whatever function that we want to carry or that we want to perform, we write a specific program or we write a code for that particular task. Right? So set of instructions is known as a program, and set of programs means a group or a collective group of the programs is known as our software. Just like we have in our computers, in our PCs, we have different softwares. So they are nothing but a set or a group of the different or definite number of programs to carry out various functions. Right? Second unit or the second component that we talked about is a resistors array. So what is register? It is basically a small storage device. Okay, so we will be basically storing certain data into those registers. But in case of microprocessor, the registers are very small or their capacity is very small. So we can only store a temporary data in there. For permanent data or for our programs to be stored, we need to use external memory. Okay, so temporarily data holding place for processing of intermediate data by mathematical or logical operation. So whatever data we need to process and whatever is our intermediate data after the processing, we can store them in our registers. Okay, it will maintain the data like instructions, storage address, characters, all that type of data we can store in our registers. We can also store the address to any memory here. Okay, then we have each register as a specific function. And what are those different registers that we can have in our microprocessor are like accumulator, we can have a program counter, we can have a stack pointer, and again we are going to discuss them in 8085 in detail. Okay, after registers we will be having a control unit. Okay, so the name itself suggests the functioning of a control unit. It will receive the signal from CPU or the processing unit to move data from place to place. Okay, so what data needs to be moved from what location to what location. Okay, so if I need a data to be moved from, let's say, input to my CPU, so that will be controlled with the help of a control unit. If I need to move the data from my CPU to output, okay, or maybe register A to accumulator to another point, so that sort of transfer of data or the signals from one point to another point on our microprocessor will be carried out with the help of a control unit. It is dedicated to coordinate data flow and signal flow through various types of buses from one place to another place. Okay, so we will be using different types of bus which are important to be discussed. Okay, because they are having some distinctions which can be asked in our prelims exam directly. Okay, it will be sending signal to ALU and registers to execute an instruction or task. Okay, so we have talked about that. It consists of multiple components. The control unit itself has a different number of components inside it, and those are basically the clock. So clock, as we discussed in our previous video also, it will be basically sending the signals to synchronize. So there are two functions of the clock here. One is to synchronize and another is to ensure timely execution of commands and processes. So whatever executions or whatever instructions that we need to follow, in order to synchronize them with each other and in order to ensure the timely execution of those instructions, we use the clock here. Okay, and basically specify it with our speed, the number of instructions that can be carried out per second by our microprocessor, right? There can be other components of the control unit itself, like a decoder. It will be decoding any instruction. So whenever a microprocessor works, it basically fetches an instruction, then it decodes it, and then it executes it, right? So that is the basic cycle of a microprocessor. So decoding is done by the controlling unit, and its control logic circuit also, they are like part of the control unit only. Okay, so these were the main three components of our microprocessor. Now, as we discussed about the buses, okay, recently. So bus, what is a bus? Bus is a wiring or a wire basically that have a specific task and function of moving data and address. Okay, so it is basically moving data or address from one location to another location. Okay, so it connects internal parts of the microprocessor unit. Okay, so let's say I need to send some signal from my control unit to my output system or output device. Okay, so this wire which is being used to send that particular signal or that data is a bus. Okay, so this is a bus here. Similarly, if I need to communicate with our memory, then control unit and memory will be communicating with the help of a bus. Okay, so there can be different type of buses. We have three types of bus. One is known as our data bus. Data bus carry the data. Okay, as the name suggests, we will be using it to carry the data. Okay, so it will carrying data to and from the memory. Okay, so basically data can be carried to and from the memory. Okay, so either towards memory or from the memory. So basically this is our system and there is a bus here which is connecting it with our memory. Okay, this is my microprocessor. Okay, so whenever I am either sending the data to memory or from memory, so this is our data bus. Okay, that is how data bus exactly functions. So it is bidirectional in nature, means it can work both ways, from this to this side as well, opposite also. And width of the data bus means width is basically the number of wires that we will be having in our bus. So width of the data bus is equal to word length of the microprocessor. So we will be discussing that shortly here. Okay. Then we can have a control bus. Control bus is to carry the control signals. Okay, so we will be carrying the control signals here, and status of the output means just like this is our microprocessor or this is our CPU and this is our output device, right? So one use of a control bus will be to send the control signal to output, and then again to send the output signal to CPU to know the status of output, whether it has changed or not. So again, it is bidirectional in nature. Okay, so we are having our control bus also bidirectional in nature. It can send either the clock signals or interrupt signals or ready signals. Interrupt signals, whenever some program is being performed by our microprocessor, if it receives an interrupt signal, it will stop performing that current program and it will execute the coming signal. And after the execution of that particular signal, it will again go back to the main program. That is how an interrupt signal works. Okay, and ready signal. So when if our external device or the device that is connected to the CPU is ready or not, so there is a ready signal for that. All those signals are communicated with the help of a control bus. Okay. Third we have is our address bus. So it is used to carry the address of memory location. Okay. So when I say that I am having a memory in our microprocessor, okay, I am having different locations onto that memory in which I have stored a data or a program. Okay, so let's say this is location 0000. Okay, so if I am talking about the data or the instruction that is stored in this particular location, so that is the address. Address is 0000. Okay, so in order to carry the address of memory location or input output ports from CPU to memory or input output port. Okay, so it is only unidirectional. So from CPU, it will be going to the memory, okay, or to the input or output devices carrying that particular address. So it is unidirectional in nature. Okay, so and that is a basic difference here. Only address bus is unidirectional in nature. Other two are bidirectional in nature, and we have total 3 types of buses in our microprocessors. Okay, next that we talk about is our cache memory, or It is basically the cache of memory to retain the last data used by CPU. Okay, and that is also temporary in nature. So when we discussed about resistors are usually store the cache memory. Okay, so that is a temporary memory. So if let's say we are doing some instruction, or we are executing some instruction, or we are using some data again and again and again. Okay, so every time my CPU needs to go to the RAM and collect the data. Okay, so there is my CPU, somewhere is my RAM, right? And it will be again and again going to this RAM and collecting that data after searching in the RAM. But what I can do, that all those frequently used data or instructions I can store in my cache memory. Okay, so it need not go to the RAM and need not analyze all of the RAM. Instead, it can directly go to the cache and it will be fetching the data very fast. Okay, so it will speed up the process, because it need not go to the RAM and do the analysis of that whole random access memory. Okay, then next we talk about the memory. To store the data and programs or the instructions, RAM store users program and constructions. So we can have different types of memories. One is known as our RAM, another is ROM, which are like very famous type of memories that we have. So RAM is used to store users program and instruction, and it is rewritable in nature. Okay, rewritable means we can write or rewrite onto the RAM. Basically, a programmer can modify the content of a RAM. Whereas ROM stores program that needs no alteration or changes. Okay, so just like our monitor program or our keyboard drive or our boot up programs. So whenever I'm switching off my computer system, the RAM data will be disappearing. It is our basically a volatile memory, but ROM data stays there. It is our permanent memory. So when I switch it on, the ROM data is still there, by virtue of which only it gets start, because it has to boot up, right? So that booting can be done with the help of ROM data. It is our permanent data. It is our volatile memory. That can be volatile means it can be changed basically. Okay, so ROM is read-only memory. RAM is random access memory. We can have other types of memory also. PROM, that is programmable ROM. So recent developments, we can have programming in our ROM also. So I can program the ROM. If I'm having a PROM type memory, means I can program it. And then we can have EPROM, means erasable programmable read-only memory. Okay, so I can erase whatever the content of that particular ROM is, and I can program it again, and then it is our ROM, means acting as a ROM only. Okay, so these are the different type of these memories that we can have. It was asked in 2017 for 5 marks. What are the different types of memories, and explain them with respect to a computer programmable system. Okay, then obviously we are going to have our input and output devices, or input and output connections. So input device to give or enter the data, means our keyboard can be there, our ADC, analog to digital converters, can be there. Output devices means it will be displaying the result, or basically it will be showing the output. It need not be a visual display only, it can be like speakers also, right? So we can have a soft copy of output, we can have a hard copy of output. Soft copy is our monitor. Okay, on monitor we cannot touch the monitor, right? So that is our soft copy. It is non-tangible in nature. Right? So non-tangible, we cannot touch it. Or we can have a hard copy like our printer, so that is tangible in nature, means we can touch it and we can change it. So whatever the printing that we have got out of a printer, I can store that paper again, right? So that is our tangible memory. Then different other elements of a microprocessor unit also we can have, like RD line, that is our read line, WR line, that is our write line. Okay, so read line and write line, they will be basically to set. Read means to obtain, and write means to set addressed location in the memory. Okay, so in order to communicate with the memory, we have our read lines and write lines. We can have clock lines to transfer the clock pulse sequence to processor. We can have reset line to restart the execution and reset the processor to 0. Okay, so we will be taking an proper example of program and in 8085, and then we will be discussing all these functions over there. One more thing that we can have is a tri-state buffer. So usually in our transistor we can have only 2 states, that is our 0 and 1. But when I talk about a tri-state buffer can go to a third state also. Okay, so other than 0 and 1, I can have a third state also, which is called as high impedance state. Okay, so that is known as high impedance state. effectively to remove the output from the circuit. So it will be basically disconnecting the circuit from our output. So I will be not having any output, I will be not having 0 or 1. Simply there will be no output because of the high impedance state of our transistor here. Okay, so these were the basic elements or the basic components of any microprocessor. Again, we are going to discuss them in 8085 in detail. And if you talk about the various characteristics of a microprocessor or a microprocessor unit, okay, so there will be they can be characterized with the help of 3 factors here. One is known as the clock speed. Okay, so you have heard that term again and again by now. Clock speed is the internal clock that regulates speed at which it means microprocessor, at which my microprocessor executes the instructions and also synchronizes it with other components. Okay, so in order to provide the synchronization and in order to execute all the instructions, we have our clock speed that will be sending the pulsed data. And clock speed can be defined as number of instructions per second, and it is measured in megahertz or gigahertz. 1 hertz is what? 1 hertz is basically a number of cycle per second. Right? That is what we mean by a hertz, or basically our instructions per second. Right? For our microprocessors, we have already discussed that we can have 1 to 4 gigahertz of clock speed. Similarly, the second parameter or the second characteristic of a microprocessor is the word size or the bus width. Okay, so when we talked about the when we had discussed our this data bus, we talked about the word length, right, or word size, or that is also known as a bus width. So it is basically the number of bits that can be processed by a microprocessor in single instruction. Okay, and we usually have wires, as I told you in case of buses, to carry out the instruction. So that wire will be carrying out the instruction, and one wire can only carry 1 bit, right? So basically what we have, that number of bits will be equal to number of wires. So when I say that I am having a 8-bit data bus, means there are 8 wires in my data bus. Okay, so the number of bits that can be processed by our microprocessor in single instruction means at one time or in one instruction it can send data along all the 8 wires, or it can send 8 bits in a single instruction. It will determine the amount of RAM that can be accessed at one go. So larger is the word size, larger RAM can be accessed at single go at one time, and the total number of pins. Okay, so a number of bits or the bus width will be determining the RAM that can be accessed as well as the total number of pins that can be that our microprocessor is going to have there. Okay, and generally the number of input pins will be equal to number of output pins in our microprocessor. And as I said that we are talking about here number of bits, right? So when the microprocessors were invented and when they were started to use, the first one was Intel 4004 and it was a 4-bit microprocessor. Okay, and that is known as our first generation microprocessor. But as we grew and as we had more inventions and technological advancements, we reached to second generation, third generation, fourth generation and fifth generation currently. So second generation is about 8-bit, okay, and third generation is about 16 bits, fourth generation naturally about 32-bit, and fifth generation is about 64 bits that we have. Okay, so that is our current system, about 32 bits and 64 bits. Okay, so that can be asked in our these objectives again, that what is the number of bits in our fourth generation microprocessor or fifth generation microprocessor, or what is the bit size that we currently have in our microprocessor. So currently we have 32 bits and 64 bits. The third characteristic of a microprocessor is given by the instruction set. So instruction is a command given to digital machine to perform an operation or task on a piece of data. Okay, so what do we mean by instruction? The command that we are giving to our digital machine, that you have to perform this, you have to execute this in this particular order. So that is what we mean by instruction. And a set of instructions is known as our program. A set of programs is known as our software, right? So first we have our command. Those commands together will be forming our instructions, right? Those instructions together will be forming our program, and those programs together will be forming our software. So that is like hierarchy, just right from our command to softwares that we can have in our systems. Okay, so instruction set is basic set of machine level instructions that a microprocessor is designed to execute. Okay, so when we talk about the instruction set, it basically means the number of instructions that my system can execute. Okay, the clock speed was the number of system that it can execute per second, and instruction set is the total number of instructions that it can execute. It's not necessary that it has to execute them at one go or at per second speed only. Okay, so that is the basic difference between instruction set and clock speed. Okay, to carry out the operations, what will be those instructions? To carry out the operations like data transfer, the arithmetic operations, logical operations, control flow, etc. we can have in our microprocessors. So all these three characteristics that we have discussed, namely the clock speed, okay, the word size or our bus width, and our instruction set. Okay, so these three values will decide the how much powerful is our microprocessor. Okay, so higher these values are, more powerful is our microprocessor. Okay, so simply when I say that I am having a 32-bit microprocessor and a 64-bit microprocessor, which is more powerful of them, then obviously 64-bit is more powerful than them. Okay, then at the same time, if I say that I am having 8-bit, okay, bits we have already discussed, right? Let's say I am having a clock speed of 1 gigahertz and I am having a clock speed of 4 gigahertz. Which of them is more powerful? Then obviously 4 gigahertz will be more powerful. Okay, so looking at the values of these three parameters, I can decide how powerful is my microprocessor exactly. Okay, so that is all about the basic architecture of the microprocessors. In our next video, we will first discuss about the basic programming, okay, or the programming that we need for the microprocessors, and after that we will jump to 8085, wherein we will basically apply all the concepts that we have studied till now and the concepts of programming also, so that it will be more clear to you what is an ALE, what is register array, what is control unit, and how exactly those things perform with each other. Okay, well, that's all for this video. Thank you for watching and best of luck.